Hello everyone, this is the first of two videos that I'm going to post. And what we're going to look at this week is we are going to look at graphics and visualization tools. We'll also look at correlation because we want to get set up for our predictive models that we're going to be doing next week. And we'll look at something called EDA, which is exploratory data analysis. It's something that's very, very common with your work you would be doing in Pandas, where you are loading up data frames. EDA is the opportunity to go in once a data frame is loaded up and take a look at it and see what's in it and try to get to know a little bit more about it. When you have a better understanding of what your data frame contains, you can make better decisions about the analysis that you want to conduct. So we'll start off with some pretty basic graphics tools. Some of these were probably covered. I don't exactly remember. I'm pretty sure they were covered in at least the intermediate Python course from DataCamp. But we'll go through them again. And then when we go through this script, I will create another video that goes through a script with a data set that you'll use that is a little bit more meaningful, where we'll actually load the data set and we'll start taking a look at it and start doing some exploratory data analysis. Okay. So, but just to kick us off, I put together the script. It contains, I think, 6 or 7 cells, and there's just different ways of being able to plot a very simple plot. The first thing we're going to do is we're going to use a couple of libraries. Now, the one that is the most common, not the end-all be-all, but it's the most common to be used for plotting and exploratory data analysis, is matplotlib/pyplot, and it is the plotting function of matplotlib. And we import that and we name it PLT because we want to type matplotlib/pyplot 100 times. So we'll go ahead and call that PLT. I commented out the pandas SPD. We use that in the next one, but we're not going to use it here because we're not actually loading and manipulating any data frames. But we are going to use, in one instance, we use, I do believe, I think I might, it's possible I removed the cell that uses this, but I'm going to leave it here anyway. Import numpy as MP, and numpy is mathematical manipulation. So we'll go ahead and run that and load those libraries. And it doesn't really show us anything, but we know they're there. We'll certainly know they're there if we try to use them and they're not available. In our first plot, this is a very, very simple first plot. We are going to plot something very simple. It's going to be a line plot. It only has 3 coordinates on the x-axis and only 3 coordinates on the y-axis. So the x-axis, we've got 1, 2, 3. On the y-axis, we've got 2, 4, and 6, which happens to be double every coordinate in the x list. These are specified as lists. You'll see the square brackets, and the numbers inside are the contents of those lists. The first thing we're going to do is we want to just plot it. Now, when you see plt.plot xy, you are looking at the simplest line plot possible. It's taking every coordinate for x and matching it with the coordinate for y, and it's placing a point there. Doesn't really show us the point because we haven't asked it to, but it will then draw a line through all 3 pairs of points. So that's what we're doing. Then we can go ahead and specify a title. That's what we do next. And the way we specify a title is we can give it the text that we want, but we can also then follow that with how do we want that text to appear. And we use a dictionary. The font dictionary, which comes next, is set equal to the contents of that dictionary. You know it's a dictionary because you have the curly brackets, right? So, and remember, in a dictionary, dictionaries are pairs of items. So the first part is the key and the second part is the value or the specification. In this particular case, we have the key being font name and font size. Those are the things that appear to the left of the colon. Font name, in our particular case, we're setting our font that we want, which is Comic Sans MS. And for font size, we're specifying that we want the font size to be 20. We put all of that dictionary within the curly brackets and we close that with the parenthesis, and we're able to set our font title, or I'm sorry, plot title. Down below, we use the PLT library again to set an X label and a Y label. And in this particular case, we're not very imaginative. We just set it as X-axis and Y-axis. But because it's a string, we could set it to whatever value that we want. We do all of that in the background. And when it's time to actually display the plot, we use the plt.show to actually display what we're plotting. Run that cell, and we see our first plot. Okay, it has the right font, it has the right font size, it has the x-axis and the y-axis, and it has a line that basically is point, point, and point. And that's the 3 pairs of points that we have here. Okay, pretty simple, pretty straightforward. We're going to move on to the next cell, and we have a little bit more complex plot. So we just expanded the number of pairs from 3 to 5. So we have 0, 0, 1, 2, 2, 4, 3, 6, and 4, 8. We're going to go ahead and run that same plot again, But in this case, it's going to draw a line through the 5 pairs of plots, starting at 0, 0, going up to plot our points 4, 8. We are going to set up a title. In this particular case, we're going to change the title to our second plot, but the font dictionary remains the same. The x-axis and y-axis labels are set. But what we've done here is we've forced tick marks. So we can specify tick marks along the x-axis and along the y-axis, and we can specify them to be appropriate for the data ranges that we're using. If you look up at our first plot, it defaulted tick marks in here, and they're like 1, 1.25, 1.5. It just threw them in and made them what fits the range of data that we have. That may not be what we want, and it may not be what we want for our visual. So we're going to go ahead and force those to actually be 0, 1 through 4 and 0, 2 through 10. And when we do plot show, you'll see that the second plot looks very much like the first plot, but we did force our tick marks to be what we wanted them to be. Moving on to the next plot, in this particular case, we're going to show what happens if how much power the actual tick marks can have over a plot. And so we set up the plot in this case to be pretty much exactly what we did before. But what we do down here on the y-axis is we set our tick marks to be a little weird. 2, 0, 2, 4, 6, and 8 are just like they were before, but instead of 10, we put 100 in here. When we run this plot, it's going to respect our specification of 100 on the y-axis, and it kind of messes up our plot because our plot now looks kind of weird, and it's not nearly as useful, but I just put that particular command in there, or that particular specification in there, to show you that when you specify those tick marks, it will do its best job to respect what you've specified there. The same thing goes if we specify tick marks that might be in between a particular range. So in this particular case, we're going to set everything up like we did before, but our Y marks, we're going to go ahead and have 0, 2, 4, 6, 8, and 10, but we also threw in 7.5. Again, it's going to respect what we put in there, and it's going to show us a plot that looks a little bit more sensical, but it threw in the 7.5. So we can put in whatever tick marks we want, whatever ones make the most sense. Now we've got this plot, and we want to be able to see kind of what this is. What does this mean? I mean, what are we actually looking at? So we can add a legend. So we're going to go ahead and set everything up like we did. We've got the x-axis and the y-axis, but in this case, the plot, the PLT plot command that we've been using, we've added something to it, and that is we are going to give the plot a label. Now we have a label. What is it that we're actually plotting on the x, y? And in this particular case, it's 2x. And that makes good sense because if you look at each of these values, what is in x is, actually what is in y is 2 times what is in x. So 2x makes sense. Okay. We're going to go ahead and set up our title. In this particular case, it's our 5th plot. We set up our labels as we had before. And we will go ahead and now specify PLT legend. And there's nothing in the parentheses, so it's going to put it in the default location. But there are 9 different locations where you can place your legend. And you can specify settings in the legend parentheses, and it will move your legend wherever you want it to be moved. But in this particular case, it's going to put it in the upper right-hand corner. Get everything set up, and we're ready to show the plot. And we have our 5th plot with our legend in the upper right-hand corner. Okay, so that's kind of a flat plot, and it's just blue, and it's kind of boring, and there's not a whole lot going on here, and it's not anything maybe we would want to include in a presentation of sorts. So we're going to add some color and some customization to our plot. And there's a ton of things you can do with these plots. And so I'm just going to give you a small little flavor of some of the stuff we can do to actually make a plot look a little bit more interesting. So we've got our setup of our X list and our Y list. And now if you take a look at our plot command, we have our XY like we had before. We specified the label like we did above. But now we're going to do a whole lot more. We're going to set up color. Okay, what color is the line going to be? We specify red. Colors always have to be in tick marks. How wide is our line supposed to be? We're going to set that to 2. You set it to whatever width you want. What line style are we going to use? We're going to use broken dash marks, again in tick marks. What is the marker going to be? In this particular case, we're actually going to specify something at each of the conjunctions of an x coordinate and a y coordinate. And what we want is we want a marker to be a period or a dot or a circle. Basically, that's how we specify a circle. It's also in tick marks. That's not going to show up very much if it's going to be buried with those dashes. So what we're going to do is we're going to specify that the marker size should be 20. We want it fairly big. So we're going to have big circular dots at every intersection of these coordinates. And this marker edge color, which kind of goes off a little bit on the edge there, we're going to specify blue. And what that's going to do is that's going to take a blue edge around each of the 5 markers that we're going to get. Remember, the markers are going to be pretty big. They're going to be red, and we're going to put a blue circle around the outside of them just because we think it looks nicer. We'll come down here and set up our title. This is our 6th plot. Font dictionary is the same. The X label and Y label is the same. We haven't changed anything there. We've gone back to standard tick marks on both the axes that we have, and we're still going to plot the legend. Okay, so everything is set up, and let's see what we get. And we get something that looks a little better, right? Our legend looks a little more interesting, and it gives us the label that we wanted. We see that we have the circular dots that we specified as our markers. We have the broken dashed line that we specified as our line style, and we also have the blue circle around the outside of each of the markers. So again, there are a million things you can do with plots, and it just becomes, as much a process of looking up and finding the specifications that you want with your plots as much as it is remembering the actual code, because there's just so much that you can do with the visualizations in Python. So that's the end of our first script. It kind of just demonstrates the power of using matplotlib pyplot and all of the things we can do with it. We went from a very simple plot, our first plot, with no customized tick marks, nothing, really just showing us our line, all the way down to something that has a little bit more specification. All right, if we wanted to save this, there is a function. I took it out. In fact, I think I might be able to put it back in. Nope, I don't have it anymore. There's a function where you can actually write out graphics, and we'll take a look at that somewhere along the line, but you could take this and you could write it out as a PNG or a JPEG file, and that will allow you then to pop it into a presentation or some document or something else. So all the work that you've done in Python can then be actually exported to some other format that would be maybe more appropriate to deliver to a management team or something like that. But anyway, this is our first script, and take a look at it, play around with it. I've given you a copy of the script. You can make changes to it. You can come down here to the one that has the markers and the colors, and you can play around with that. Really, it's just for your practice. Okay, that's it for this video.